Okay, this video is going to show us different ways we can do what I'm going to refer to as string manipulation in Python. And there's several different things we can mean by that, several different things we can do. So kind of the simplest is using the replace method, which is part of the string class. So that means it's built into Python. And this is going to be used for what I'm going to call simple replacements. And to me, that means things that do not involve regular expressions. So the way we do this is we have a string str, and like I said, replace is a method that is part of the string class. So we say string.replace, and then we give it an old string and a new string. In some languages, or some people might refer to that as a search string and a replacement string. And whatever the result is of doing that replace in this example would be assigned to new string. Now we can repeat the string on the left-hand side of the assignment statement. So we can take a string, call the replace method on it, and whatever the result is, we can stuff that back into the original string, in this case str. So let's look at some examples of doing this. So I define a string that says this are a test. I then call the replace method saying look for r and replace it with is, assign that back to string, and then print the string out. And if I do that, the string this are a test becomes this is a test. So r was replaced with is. There is a sub method in the re module. So this allows you to do replacements where the search string is a regular expression. So the syntax of doing this is, of course, we have to import the regular expression module re, and then we can say re.sub, and we have different parts here. So regex is, string, the third argument, is the string we're going to process. And the first argument, regex, is the regular expression we're searching for. And then replacement is if we match that regular expression, replace it with whatever the second argument is. And we can have an optional count, and we can have an optional flags. Count limits how many times the search and replace is going to happen, and I do have an example of that coming up. So here we have some code. We're going to import the re module, and I have a string that says Mr. Greenfield's coat is green. And then I'm going to do a substitute using a regular expression that has word boundaries in it, the \b. That r basically says this is a raw string. So the raw string means we don't have to worry about escaping things like backslashes and asterisks and that type of thing. So a lot of times when you use regular expressions, you're going to use that r qualifier on a string to say this is a raw string. So if we have the word green, replace it with mauve, and do that in the string called str. Once that substitution happens, we're going to print out the string. So if we were to execute this little segment of code, we would get Mr. Greenfield's coat is mauve. So if we did not have the word boundaries, it would have changed this to Mr. Mauvefield's coat is mauve, which is obviously not what we would want to happen. So we put the word boundaries around the word green, so it only replaces the word green. Another example is, again, we import the re, we set string to the value of pi, and then we're going to say in the place of \d, which is a character class that you should know is for digits, replace it with nothing, and do that to str, and then print the result out. So if we were to do that, it's going to result in a period. So it's basically going to remove all the digits. And the reason that happened is because the default on the SUB method is to do every occurrence of the regular expression. So if that's not really what we wanted to happen, and this is a little bit different than what would happen in Perl, for example, but if we just wanted to replace that first digit, we could have basically the same code. The only difference is when we call that sub method, notice that there is a third argument that is set to 1. So find the regular expression, replace it with nothing in the variable str, but only do it one time is what that method call is doing. So if we were to execute this code, then just the first digit, just the 3, disappears, and we're left with 0.14159. Hopefully you have watched the video that talks about back references and know how important and handy back references can be. So I'm going to show you an example of using the sub method of the regular expression library, and we will also use back references. So for this discussion, here's the code I want to talk about. We're going to import the regular expression module. We have a string that is word 1 and, like 6 spaces, word 2. And then we're going to do a substitution. So the first substitution I had used in a previous video, \S \S plus \S plus. So find occurrence of non-white space followed by occurrences of white space followed by occurrences of non-white space is what that regular expression is. And then because I have parentheses, the first one is going to remember the first set of non-white space. The second one is going to remember the second occurrence of non-white space. And then notice that the replacement, I have \2 \1. So the back references are numbered in the order they occur. So the stuff we remember in the first set of parentheses, we can reference as \1 in the case of the sub module, and then, the sub method. And then the second match we can refer to as \2. So do the match and then replace it with those back references and then print out the result. So what'll happen is the first back reference will remember word 1, the second back reference will remember word 2, and the output is going to be word 2 space word 1. So basically we're replacing 2 words in a variable. Now if we needed to preserve the white space between those 2 words, then we would have had to put a back reference around the \lowercase s plus that remembers that white space. And then it would be like \3 \2 \1 to replace those, reverse them, preserving the space between the 2 words, again, if that's what we needed to do. Another way we can manipulate strings is using the translate method. This is a method that is part of the string class, so it's built in to Python. And basically we're going to have a list or a mapping that says, the first character here replaced with the first character in this map, the second character here replaced with the second character in the map, etc. So when we use this, we are going to say some new string equals an existing string dot translate search list and replacement list. Here's some examples. I set a string to A, B, C, D, E, F, C, B, A, and then I make a translation table, which is going to basically say, if I have a lowercase a, replace it with lowercase x. If I have a lowercase b, replace it with lowercase y. So character for character in these two strings specifies the replacement. Now, what this really wants is a dictionary that has the mapping, the key value pair. The key would be what you're searching for, the value would be what you're replacing it with. And Python gives us a translate, a make trans, which makes a translation map, so that we don't have to build that associative array. Associative arrays are Perl. Don't have to build that dictionary, same thing. And we assign that to map. And then we can call the translate method passing that translation map in. And then in this case, we print out a string. So what's going to happen is the output is going to be this. Notice A was changed to X, B was changed to Y, C was changed to Z, etc. Now characters that we did not match, in this case E and F, they are not translated, but they remain in the string. Another example of this would be doing this. So there's going to be some setup required for this, and in Python this setup is a little bit more of a pain than it would be, for example, in Perl, because I have to go through and basically iterate over a range. So in this example, I am using the ORD function, which will basically give me a numeric value for the character specified. And the way the character set for ASCII is set up, B is 1 more than A, C is 2 more than A, etc. So it's basically in consecutive numerical order. So I can say for A to lowercase z, append those characters into a variable that I'm calling lower, and then I can do the same thing for upper using the ORD function for capital A through capital Z. Notice on my assignment statements, because I converted those values to numeric values so that I could use the range function, I have to use CHR to convert those numeric values back to ASCII characters. So I build the lowercase letters and the uppercase letters, and then I have a string that says this is a mixed case string with kind of alternating capital and lowercase letters. And then I make my translation table using upper and lower, and then I translate using that table the contents of string, and then I print string out. So when I do that, the output is going to be this is a mixed case string. However, it's going to be in all lowercase because I mapped the uppercase letters or translated them from uppercase to lowercase. Here's another example. This example, which is going to ultimately be 2 or 3 slides depending on how you count it. In Perl, you could do with 1 line of code. So usually Python makes things more efficient, but when you're working for this, because it does not really allow you to use character classes, it's a little bit more of a pain. So what I have here is I'm basically, like I did in the previous example, building a string called orig, that's going to have all the capital letters followed by all the lowercase letters. And then I'm going to do the same thing, or at least a similar thing, for the variable new. And what I'm going to do is I'm first going to put capital N through capital Z, followed by capital A to capital M. And then on to the end of that, I'm going to put lowercase n through lowercase z, followed by lowercase a, all the way up to lowercase m. And then once I've done that setup, I'm going to execute my code. So I have a string that says this is my message, and then I'm going to make a translation map or translation table using my what I called a ridge, and translate that into what I'm calling new. I'm going to then use that translation table on my string, and then I'm going to print the result of the string, which comes out to be this. Now, people these days are not familiar with the process that I have implemented here in this example, but it's called, every now and then in class, if I ask a student, will come up with one of two terms that is correct. Some people would say this is a Caesar cipher, which is true, but more specifically, it is something called ROT13 encryption. ROT13 stands for rotate 13. So basically what you do is you add some value, in this case 13, to the character value. If you go off the end of the list of characters, you rotate back to the beginning and basically shift these by 13. And to reverse this process, you would do the translation reversing in your translation table, new and original, and you would get the original message back. So students used to be more familiar with this. Before the World Wide Web existed, there was something called Usenet. And what happened is if you told a joke, for example, in a news group that might offend somebody, what you would do is you would ROT 13, and then you say something like, the following might be offensive to people who have blonde hair. It's going to be a blonde joke. If you're going to be offended by this, just move on to the next message and ignore this one. But if you want to hear the blonde joke, then apply ROT 13 encryption again, and you will get the original message back. So those are some examples of how we can do some string manipulation that we haven't talked about yet in Python.